Hi, I'm Curt Beckmann, Principal Architect here at Brocade and also Chair at Open Networking Foundation Forwarding Abstractions Working Group and a member of their Chipmakers Advisory Board. I'm going to do my usual ONF update. Previously I've talked about most of this slide. I'll throw it up there, it'll show up in the video, but mostly I'm just going to talk about this section toward the end because for the most part you've heard me go on about the other part. So we've already heard a bit about NFV. It's obviously impacting ONF and SDN generally. The Open Daylight project is also impacting ONF in a positive way, and I'll get into some of this as we go forward. So I got basically speaker notes on my slides. I'll sail past them, but that way people don't have to take notes. They can just pause and look at the slides. For ages, there's been a big attitude shift at the ONF in the last year or so. This is wonderful and overdue. For a long time, it was all about me, my feature. And I wanted more flexibility and more optical and more wireless and more everything, you know, solar, nuclear, everything. They really want a fully programmable data plane, which is really unrealistic. They wanted protocol-independent verbs, you know, so that they go down there and massage any byte or bit anywhere in the packet, even though really you wouldn't be able to write code based on that, because if you're going to write something out of layer 3, you want it to be independent of layer 2, but then if you're setting packet offsets, that just doesn't work. And as it happens, the chips don't do that either. The revolution was all focused on the revolution and not worried about how stuff was going to work, you know, after the revolution, like, oh, the phones and electricity and water and trash pickup. That's somebody else's problem. You know, I just want the revolution to win. And you know, they figure, well, this is all going to work great when the new chips come out. And the new chips, you know, new chips take 2 years, right? Well, 2 years happened, and there's no new chips, or you know, no revolutionary new chips, and that's because they didn't understand the business model for chip making. And the Chipmakers Advisory Board has helped in that way. So the shift in the ONF has been more toward, hey, we need to get stuff working. And I think to some degree, as I mentioned earlier, Open Daylight has been helpful. I'll talk more about that in a minute. So now we've got OpenFlow 1.3. I mean, we sort of skipped past 1.1, 1.2. Those were there. Nobody really delivered product on them. ONF sort of wisely decided, hey, maybe we should slow down a little bit and focus on a release. And now a bunch of products have early 1.3 capabilities in them. We did a plug fest in November. It was all 1.3. But gosh, you know, it didn't all work that well together. And tell me again how I write code for features I'm not sure are going to be there in the devices. How does that work? And how do I test those? How do I create a test plan for 1.3 when, you know, 2/3 of the functionality doesn't have to be in the product? And like OpenFlow config, not required. So how do you write tests and write apps based on this fluid environment? Test and interop. The working group that runs the Plug Fest saw all this. They kind of saw it coming, and so did Forwarding Abstractions. In fact, it was a crowd of people that saw this coming back in 2011 and started working toward it, and that was actually through that I got really close to Dave. He was the vice chair of that working group for a while until we were both at Brocade, and then they thought, well, maybe we should spread the love. So we realized that all this stuff was hard to work on existing chips, and we needed to make it work on existing chips in order to have a business case. And that's what the Chipmakers Advisory Board explained to the higher-ups at the ONF, that it costs $50 million to develop a new chip, and you need to know that you're going to sell it. Right now the specs are too variable, the market's not clear. You know, do you need this in your core network, at the top of rack? Where are you going to sell this? We know SDN's big, we don't have clear requirements. I'm not in a position to spend $50 million just because you guys think that's a nice idea. So once they understood this, you know, things have sort of shifted as well. What you really need to do is to ship existing products, and then that'll get us excited about building the next generation of products. So a number of other things have happened. You know, I mentioned OF config. OF config is kind of oriented towards configuration. It's based on netconf. Netconf is focused on managing persistent management state. So what's going to survive after a reset? Well, it's actually a good protocol for that, but persistence comes at a cost. And in SDN, it's like, well, I'm expecting my controller to remember stuff. I'm supposed to be a switch that does what my controller tells me. Of course, there's times you want the switch to remember, but with OFConfig, you don't really have the choice. You have to remember in the switch, and that implies some overhead. So there's a number of other problems between OpenFlow config and OpenFlow switch, and it seemed like for a long time in the ONF you couldn't talk about that. You would talk about it, but they'd say, yeah, it's not really a problem. Or another part of the issue was that there's the OFConfig working group, or the config working group, and there's the extensibility working group. Extensibility is responsible for OpenFlow switch. Config working group responsible for OFConfig, and the fact that there's a gap between those doesn't really belong to either working group. And so there's a bunch of stuff that you want to manage. You'd kind of prefer to manage it in OpenFlow switch, but it's not there. He says, no, that stuff belongs in OpenFlow config, and OpenFlow config says, sure, except it's got this persistence overhead. You have to write everything to flash or some other persistent memory. That's pricey in terms of implementation. Now the good news is that we're able to talk about this now, but there is the ownership problem. Another thing that happened was architecture working group got fixed. For about a year, essentially the chair of the architecture working group was at Big Switch, and Big Switch had a bomb drop on him about a year ago in the form of Open Daylight. And the chair of that working group was investing less and less time in architecture. And architecture was a really hard problem. Very often, if people start big projects, they architect it first, and then they start to build it. Well, OpenFlow, we went and built it first, and then the architecture is coming along later. And so it's trying to keep up, get caught up, and architect it in such a way that that it supports everything we've already built, because you really don't want to, throw the baby out with the bathwater. But as I said, the chair was swamped, and not much happened in architecture for a long time. Well, Rob stepped down, Fabian stepped up, and now there's more progress in architecture, and a lot of other things have happened in parallel. So there's been progress in optical, progress in wireless. Open Daylight really drove forward the architecture picture as well, and so now architecture is getting serious. They're having regular meetings. They when they first formed the architecture group, they absorbed the northbound interface activities into architecture. That basically stalled any NBI work. As a part of this revamp of architecture and the new leadership, they also spun back out NBI. This sort of sounded like some of the corporate spin-in, spin-out models that you're like, well, why did they acquire it in the first place? I don't know. And now we might also ask, in the presence of Open Daylight, which is going to, I think, give us the northbound interfaces, do we really need an NBI group in ONF? But I'm not too worried. I think we need folks in ONF who are paying attention to the northbound interface. The idea that we might standardize it, I think, is unlikely. But I'm not running that show, so but I'm not too worried. A few other things have happened. Number 3, Daylight, Open Daylight. I already mentioned that quite a bit. And it's not magic. It's kind of what Dave was saying. The fact is that, as he says, code is the coin of the realm. That's cool because people are out there writing code. That's not so much the case in ONF. ONF doing a standard, that's good because it applies to hardware. And when you're doing hardware, you need to have something that holds still. Actually, if you're doing open source, you'd rather not have something that holds still. I want to be able to iterate quickly. It doesn't cost me a lot like it does to iterate hardware. It doesn't have a huge lead time. Just get the hell out of my way, please, and let me go. So that reality, the fact that code is driving it, means that the stuff's kind of got to work or nobody cares. So I love that. It's pushing it forward, and that's actually good for ONF to sort of have something upward in a way that is stabilizing or coming into stabilization versus a proliferation of controllers. We still have a lot of work to do. I would say the ONF honchos, they didn't know exactly how to talk about it. And given their position and that they've got a bunch of microphones in their face, they need to know what to say. But it was difficult for them, and I think they were kind of squirrely and thinking that they needed to be able to set direction based on their attitudes about ONF. Well, the reality is for the people doing the stuff in the ONF members, doers, they don't care about the position about Open Daylight. They just want to go get stuff done. So the fact that we didn't quite know our position about it in an organization was not an impediment. In fact, to some degree, it sort of helped things crank along. My working group, Forwarding Abstractions, has also gotten a bit better at, we've gotten closer to fruition. We're very, sometime in May, I expect that we'll go out with our early publication of the spec while it's under a member review. We've got better at talking about it, and so partly people have understood, gotten more familiar as things didn't work, like at the Plug Fest and so on. And then also, just over repetition and clarification, we've gotten better at explaining it. And there's folks in the Chip Makers Advisory Board, they really get this because they come at it from that perspective. Colin Dixon, that Dave already mentioned, was very active in our working group back when. He's an amazing guy because he sits in research. He's kind of a software guy. He works very closely with, well, he did until IBM sold off their hardware, but he really did act as this phenomenal bridge between a number of groups. And David Erickson also understands this stuff as well. So essentially things are shifting gears now. Oh, I went past earlier, I made a reference to really soft chips, very programmable chips. And there's a paper, Nick McEwen's one of the authors, about a metamorphosis chip, and that was published, I'd say, last June. It's all about the soft chip. The soft chip is a buildable chip, and kind of nudging why isn't the industry building this? And I already mentioned the reason the industry is not building it is because there's not a good business case. It's not a technical question. It's not, can you build this chip? It's, if I built this chip, would I get my money back and a little bit more, right? What's interesting is this paper, if you go search, it hasn't really been published, but you can find it. It's a publicly available PDF and an archive thing. Barefoot Networks, some of the same people that wrote that paper 6 or 7 months ago about metamorphosis, they have a slightly different take now. And I think this is really interesting, given that it was about 6 months ago that the Chip Makers Advisory Board explained to them that they aren't going to get new chips anytime soon. And now they're shifting gears and starting to talk about that you need to compile in advance. Essentially, they had this, oh, I want to be able to, on the fly, change the pipeline in the network just because I feel like it. But network operators don't like that idea. It's like, no, I want the thing to work the way it did in my lab. I don't want it to work different because you sent some new pipeline instruction. So if it's going to work the same as it did in the lab, well, then you have some, the life cycle is actually longer than, whatever you sent this minute. You have to, the life cycle of any kind of functionality. So the functionality's got to be a little bit more baked, a little bit better understood. The notion of compiling and analysis and so on makes more sense. And if you go look at this Barefoot Networks paper, it's really indicative. Nick is also an author on this Barefoot Networks paper, and there's many authors in common, in fact. And so it really is signaling this shift from some sort of this cowboy notion in your highly important, highly sensitive production network, but we're going to do things a little differently. And that is the end of my talk. So did I leave John any time? No, -2 minutes or something.